The Falling Walls Science Breakthrough of the Year in Art and Science. Dear guests, please welcome Jury Vice Chair, Christina Landbrecht, Schering Stiftung.
Very happy to be here. Marco Barotti is a media artist, and he's also the winner of the Art and Science Breakthrough Award 2025. Barotti combines biology, music, sound, and robotics. And currently, for the past 5 years, he's been experimenting with sound in coral reefs. Those reefs, as you may have heard, when a report was recently published by the Potsdam Institute for Climate Impact Research, are at risk of dying out due to global warming approaching critical tipping points. Barotti's project, Coral Sonic Resilience, takes a stand against this. The sound of a healthy reef is played to a damaged one, and as if lured by a siren song, fish and other sea animals follow the choral melodies and return to repopulate the reef. We, the jury, consider this a breakthrough. And on behalf of all the members of the jury, I congratulate Marco Barotti for winning this award.
Breaking the wall of ecological healing through sound. How underwater installations can revitalize natural environments. Marco Barotti. Marco Barotti Studio.
On November 9th, 1989, I was a small kid in Italy. I remember watching Roger Waters' concert The Wall on TV with my brother and feeling something huge was happening. Who would have thought that years later I would end up living here?
This was the sound of a healthy coral reef, alive with crackles, pops, clicks, and low-frequency hums made by fish, shrimp, and other marine organisms. These sounds are not just beautiful and cosmic, they are vital. Young corals and fish larvae, they use sound to navigate and to locate suitable habitats to settle and grow. So in other words, if a reef is alive with sound, it's most likely to stay alive. But when reefs degrade, they grow silent. Coral reefs are fundamental to life on Earth. They provide incredible benefits to human and more than human communities. They offer food, shelter, ingredients for pharmaceuticals, carbon storage, and much more. They support the life of 1/4 of marine species, even if they cover only the 1% of the vast ocean floor. They are incredible, aren't they? Unfortunately, the reefs are in crisis. Around 50% of the world coral reef, they have been lost or severely damaged. And about 90%, scientists says, it could disappear by 2050. Coral bleaching, which is happening when stressed corals expel the algae that live in symbiosis with them, is becoming more frequent and severe. So these impacts are not just single events anymore. They are part of a larger pattern that shows us how climate change and human activities are pushing ecosystems beyond their limits. So protecting corals is not just an act of conservation. It's an act of care, reciprocity, and justice. When we safeguard coral ecosystems, or any ecosystem, we also nurture the intricate web of life that binds us all together. I have a background in music, and sound has always been the core of my work. For me, it's not just a medium, it's a way of sensing, connecting, and understanding. Through sound, I try to open a space where data becomes experience, and where listening becomes a form of awareness, engagement, and repair. I create interventions in urban and natural environments. They are data-driven, kinetic sound sculptures that resemble animals and plants and deal with environmental and social issues. In every work, I try to recreate the biology and the functionality of specific species in nature through technology. I collaborate closely with scientists, and I use environmental data sonification to bring critical topics to the audience in a more tangible, sensitive, and poetical way. And today, I'm here to share with you my new artwork. Coral Sonic Resilience is an interdisciplinary art and science collaboration rooted on acoustic ecology. It explores how the soundscapes of healthy reefs can actually support the recovery of damaged ones. The work builds on the research of Professor Timothy Lamont from Lancaster University. In the Great Barrier Reef, Professor Lamont applied a technique called acoustic enrichment. He recorded the soundscapes of healthy reefs in multiple locations, and then he played those sounds back into degraded colonies using underwater loudspeakers, like that one. Over 40 days, his research proved that fish and other marine organisms came back to the degraded colonies because of sound. I got fascinated with the concept of acoustic enrichment and by the idea that sound can actually heal an ecosystem. Well, more than fascinated, I would say I got obsessed with it. And I tell you why. In my previous work about corals, I developed what I call techno-shamans. Techno-shamans are algorithms trained on shamanistic music from South Korea, South America, and Japan. The aim of the artwork was to create speculative healing rituals for corals using bleaching and ocean datasets. It was an artistic exploration to heal the reefs through sound. So when I found out the scientists were doing in real life what my speculative artwork was trying to do metaphorically, a new path opened up. I started diving into acoustic ecology, asking myself, how can sound and art become an act of repair, contributing directly to ecological recovery? So for the first time, I made a work not for humans, but for fish and corals. Okay, here we go. Thank you. Thank you. Okay, the applause in the middle never happened, so thank you very much. I was very convincing until now. Let's see what I do now. So the sculptures are 3D printed using ceramic and calcium carbonate. They are materials which reflect the natural composition of corals. The design and textures is based on 3D scans of bleached corals and is thought to invite marine life to shelter, to settle and grow. This photo is taken in Feridu Island in the Maldives, where together with the University of Padua, I went to record the soundscapes of healthy reefs and to install the sculptures in damaged areas and coral nurseries. Over several weeks, we collected different types of data, and we ran many tests to optimize both the sculptures and the solar power station. The floating solar station is actually providing clean and autonomous energy. It captures sunlight through photovoltaic panels and converts it into electricity to power the sound system and so the underwater loudspeakers. The buoy is designed in Berlin and is thought to fit inside a small suitcase to be easily transported and installed anywhere and to enable sound installation in remote marine environments. The soundscapes were recorded in 4 different healthy reefs around Feridu Island. And in order to portray, let's say, a healthy marine environment. After the installation and after the recording, we put together sort of, how do you say, a picture of the soundscapes of the healthy reefs of Feridu. Now that we are ready for the new setup, we are going back to the Maldives in February 2026 to install new sculptures, and a marine biologist on site will then collect coral and fish growth over several months. And a scientific paper will be published by the end of 2026. Beside the Maldives, the project will go to Jamaica, to Bahrain, and hopefully in Singapore. So now, coral sonic resilience is evolving into a body of work, right? Parallel to the underwater artwork, I'm developing new iterations of the project for art exhibitions above water for human audiences. The journey starts right here at Falling Walls and Science Week, and it will continue to national and international venues at ZKM in Karlsruhe, Art and Science Museum in Singapore, Science Gallery in Melbourne, and Ocean Space for the Venice Biennale of Architecture in 2027. And whether the artwork is installed underwater or in a gallery, it is driven by the same purpose: to change our perspective, to invite new ways of listening, and to engage with and to protect the fragile ecologies we are part of. In this way, coral sonic resilience is not only exposing a crisis, it takes part in it, intervenes, and proposes new models of coexistence and regeneration. Thank you.